So for our number 29, it's telling us to find two different combinations of three vectors u, v, and w that produce the vector 0, 1. So the combinations, we're just going to put a random scalar c times u, so that's 1, 3, plus d times v, which is 2, 7, plus e times w, which is 1, 5. This is going to give us, supposed to give us 0, 1. Okay, so we have a problem because we have three unknowns, c, d, e, but we can only make two equations. We could make the equation 1c plus 2d plus 1e is equal to 0, and then the equation 3c plus 7d plus 5e is equal to 1. So we're going to have two equations, three unknowns, and this is a problem, right? We wouldn't be able to find any solutions. So what we can do here is we can artificially just reduce it to two unknowns by saying, okay, let e be equal to 0, which is valid, right? This is still a linear combination. So if e is equal to 0, then the whole 1, 5, that's going to go to the 0 vector. So if this is equal to 0, we're just going to have that 1c plus 2d plus 0, 1 is going to be equal to 0. And then we're going to have that 3c plus 7d plus 0, plus 0 times 5 is going to be equal to 1. Okay, so because these are all going to be 0, I'm just going to remove them. They're just going to give us 0. Okay, and once we do this, let me just move these here to the left. Okay, and so once we do this, I'm going to take the first equation here and then just say, okay, 1c, I'm going to bring the 2d over to the other side. So 1c is equal to negative 2d. And then once I have this, I'm going to substitute it back in here. So when I substitute this back in there, I'm going to have 3 times, remember that c is equal to negative 2d, and then plus 7d is equal to 1. And so that's going to be minus 6d plus 7d is equal to 1. And therefore, I'm going to have that d is equal to 1. Okay, cool. So if I have that d is equal to 1, e is equal to 0. And now if I plug in the d is equal to 1 back here, what I'm going to do is just plug it in here. So equal to 1. And so we have that c is going to be equal to negative 2 times 1 to negative 2. Okay, so the first combination is going to be the combination negative 2, 1, 0. Now let's find a second combination. Of course, there are infinite combinations, but we'll find the second one. And this time we're going to set the middle one, d, to 0. So we're going to say, okay, d, different color. So we're going to say that d is equal to 0. So let's do the equation. So 1c, d is equal to 0, so we're just going to leave that out. Plus 1e is equal to 0, and then we have that 3c plus 5e is equal to 1. So this one, I'm going to bring the e to the other side, so we have here that c is equal to negative e, and if c is equal to negative e, now I'm going to substitute this in here. So I have that 3 times negative e plus 5e is equal to 1, and then this is going to give us, let's see, negative 3e plus 5e, so I have that 2e is equal to 1, and so e is equal to 1/2. So I have my d, I have my e, and remember that c is just equal to negative e, so c is going to be equal to negative 1/2. So the other possible combination is negative 1/2, 0, 1/2. But then you could also have let c is equal to 0 and so on. And so there are quite many ways that you could have done this. Okay, so we have found two different combinations. And the next thing is they ask us, if I take any three vectors u, v, w in the plane, so it is a 2D plane, right? So it is, and I'm going to draw this in. So we're dealing here with a 2D plane, and B is going to be at 0, 1. So this is going to be B. And then it's asking, in this plane here, if I take any three vectors u, v, w, will there always be two different combinations that produce b? And the answer is no, because what if I had that my vector, this would be my vector u, and then my vector v is going to still be on this line, so it's going to extend further. My vector v is going to extend further. And then my vector w is also going to extend further. Here. So we could see that all of these are on the same line, right? And so because all of these are on the same line, they can never access b. b is completely different. So in the case that all three vectors are collinear and b is outside that line, then no combination here could ever be equal to b, because they're just basically stuck on this line here forever and ever. And that is it for item 29.